Hello, good morning. Of nature of radiation. In some of the experimental observations, radiation behaves as a wave having certain wavelength and frequency. For example, interference, Young's double slit experiment, diffraction, single slit diffraction, polarization, polarized glass. In some of the experiment, observation radiation behaves as wave having certain wavelength and frequency. Use double slit experiment, single slit diffraction, polarization glass. In some experimental observation radius behaves as a string of particles. For example, discrete emission observation, Bohr, black body radiation, photoelectric radiation. The same entity, same time behaves as wave and same time particles. This nature of radiation is called wave particles duality. According to Planck's theory of radiation, the energy of photon of energy is given by E equal to hv, where yes, Planck's constant 6.602 to 10 to the power minus 34 joule per second be frequency, so that E equals Hc over lambda, B is C over lambda. C velocity of light or speed of radiation, photon in year, lambda wavelength of radiation. According to mass energy equation relation, E equal to mc square, mass of photon from equation 2 and 3, Hc over lambda equal to mc square, lambda equal to h over mc. Equation 4 gives a linkage between wave nature and particle nature of radiation. De Broglie proposed that a moving material particle is also associated with moving particle is known as de Broglie wave or material wave. For a particle of mass moving with speed v, the de Broglie wavelength is given by lambda equal to h over mv for material particle. The measurement of de Broglie wavelength of any particle is significant linear dimension of any object is comparable to de Broglie wavelength. For example, for a particle of mass of 65 kg moving with speed 10 meters per second, the de Broglie wavelength is lambda equal to h over mv 10 to the power minus 36 meter. The linear dimension of object is approximately 0.1 meter to 1 meter. In this case, the measurement of de Broglie wavelength is not significant. That is, the wave behavior of that particle is not observable. For an electron revolving in orbit of hydrogen atom, mass of electron 9.1 10 to the power minus 31 kg. Speed of electron is first orbit. V dash equal to V over C. We know that MBR equal to N is over 2 pi. If N equal to 1, V equal to is over 2 pi MR. So V equal to 2.89 10 to the power 6 meter per second. Media is equal to V over C. That is 1 over 137. The de Broglie wavelength of electron H over MB. So we get lambda equal to 3.3 Armstrong. Perimeter of first orbit to per r. So 3.3 Armstrong. In this case, electron behaves as a wave having the wavelength of the order 3.3 Armstrong, having the wavelength of the order 3.3 Armstrong. Okay, it's all about wave nature of radiation. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for your patience. Let us know. Bye bye. See you again.